Quantum physics is a branch of physics that is in search of the underlying principles which can connect all the major theories which explain the working of our universe, like the theory of relativity and the quantum theory itself. Here, we are only considering the possibility where we are definite that there is a common ground between theory of relativity and quantum physics. But there was a physicist who said, accept the facts as they appear and don't try to make connections. He was Hugh Everett, a young physicist. Hi, I am Vivek and this is Exposed. Today, with yet another intriguing video. Today, we are going to explore one of the popular and also complicated phenomena of quantum physics, that is, quantum entanglement. The basic understanding, and which is also a thing that almost everyone knows, is that something is locked with something else. But the common mistake which we all do is that to think two particles or two objects are physically trapped. But this is not the case. What happens is a quality that has two different attributes will be entangled between two particles. That means if an observer observes an attribute associated with a particle, automatically the other particle acquires the other attributes. For example, the spins of an electron which has upspin and downspin, those are the attributes which are entangled between two electrons, but electrons can be anywhere. And as the early quantum physicists have explained, every event in a quantum system appears only when there is an interaction between two particles. This makes this phenomena of entanglement even more complex as there is no definite initial state for any particle. It depends on the interaction. Consider a pair of gloves. I gave a glove to Alice and Bob who are on two different corners of the globe. Then I know which glove I gave to Alice and Bob. But Alice and Bob know the moment they see the glove which glove the other has. Here the result is entangled but with a fixed initial value which I knew. But this is not the case with quantum entanglement because here the initial state is undeterminable. The result can change according to the time the observer observes the particle. Einstein observed this in the year 1935 and said this is not right because this violates the special theory of relativity, as there can't be anything faster than light. He called this a spooky action at distance and said this is not the full picture, and he introduced a new concept of hidden variables. The introduction of these hidden variables made the quantum entanglement the same as the situation as the gloves, because Einstein said the attributes of a particular particle are predetermined but hidden until the interaction. But all the physicists at that time believed that the action is actually instantaneous, so it defies special theory of relativity. To prove this came John Bell with a very complicated thought experiment which made things difficult for even physicists. I am not going to explain the experiment here because I personally don't understand the experiment perfectly. I leave the link in the description for videos explaining the experiment alone. But today we have technologies which can actually prove the experiment being true and it disobeying special theory of relativity. Understanding this and finding a solution which can prove both the sides of story is another avenue which is keeping physicists busy. This leads to the next topic of this video, quantum non-locality. The explanation they gave to this anomalous behavior is a specialized name with a bunch of equations which has a product which we want to see. But in reality, this does not say why it is defying the special theory of relativity. To understand non-locality, consider two electrons with different spins which are entangled and which are at two ends of a galaxy. Non-locality says how much ever the distance between the entangled particles, they can communicate instantaneously when an observer observes one of the particles. That means if I see an electron and observe the upspin, instantaneously the other will have the downspin. This is confirmed by experiments. But it is a mystery why it actually waits for an observer to observe. Think about it. I am Vivek and this is Exposed. Peace out.